Hello and welcome to session 6 of the massive open online course for the University of Nicosia's digital master's degree in digital currencies. I hope you're all doing well and having a great week so far. Let's do a quick check. You can see, fantastic. Audio and video, excellent. I can't promise it will remain excellent. We'll see about that. The video may go down in quality. Let's hope it stays. Great questions this week. Let's dive right in. First question comes from Albert. Is a colored coin a meta coin? So Albert, the has only been used by me. I coined the term, if you like, back in 2014 when writing Mastering Bitcoin First Edition. And I wanted to differentiate between coins that have their own blockchain, coins that were called altcoins at the time, and coins that use metadata on top of another blockchain. Nowadays, that term I don't think is that useful because that distinction is a bit blurred. So coins that use metadata on top of an existing block, colored coins are, according to my definition, meta coins. They do not have their own blockchain. They use metadata in order to exist on top of another blockchain. In the particular case of colored coins, that usually refers to the Bitcoin blockchain. But nowadays, we have all of these tokens. And tokens could, in some ways, be considered meta coins because they are metadata on top of Ethereum. But then again, not really metadata. They're full smart contracts. So that definition is a bit blurry nowadays. Let's go to the second question. Albert asks, how would the color coin appear on a blockchain? Can a transaction involve the color coin be distinguished from an ordinary transaction? Yes, Albert, it can. On the blockchain, what you will see is within first to a color additional data, an op return code. And what the op return code does is it is a non-spendable output that contains up to 80 bytes of data. And these 80 bytes usually have some kind of signature, some kind of prefix that identifies which protocol they're using. So, for example, if it's a certain type of colored coin, like the implementation from Colu or the open ASIC coin, then the first two characters will actually identify it as such. Transaction is part of some kind of secondary counterparty. Omni, again, the op return will contain a prefix that identifies it as an omni metadata or as counterparty metadata. And so as a result, you can identify colored coins and transactions happening on secondary layers like counterparty and omni on the blockchain. Vikas asks a similar question. In regards to colored coins, how is a Genesis transaction created? Is the Genesis transaction part of the Genesis block? No, it's not, Vikas. A Genesis transaction is a transaction on Bitcoin that has within it an op return. And that op return identifies that a new colored coin has been created. And the op return itself would have some kind of prefix identifying which colored coin protocol is being used, and would color the specific coins in that transaction with the new metadata for this new form of colored coin created. So the fact that it's called a Genesis is, I agree with the term Genesis in Bitcoin. It's the genesis of that colored coin. And again, Genesis is simply the Greek word for birth. So it's the transit to that colored coin. Sudhakar asks, what's the difference between coins and tokens? Can this be defined in layman terms? What a great question, Sudhakar. And I've been wanting to talk about this for a while because people use these terms interchangeably. I think a good definition is this. A coin has its own blockchain. A token does not. A token usually is implemented on top of a coin. So, for example, the various tokens that are used in Counterparty and Omni and colored coins, those are all tokens, and they work on top of Bitcoin, which is a coin with its own blockchain. All of the ERC20 tokens and other standardized tokens, ERC721 tokens, that exist in Ethereum. Those are all tokens, blockchain, they are blockchain. So these triply, and it's very, very confusing for most new users. I think one way to remove the ambiguity a bit, and rule, and it will probably, is to blockchain do not have their own blockchain, but operate on top of another blockchain smart contract or secondary layer tokens. Sudhakar asks, is a smart legally happens? What is a smart contract? That's not a contract. A smart contract is a dumb program. Is a program written in a language that is executed inside a blockchain-based virtual machine. It's a program, and they're not particularly smart. They're fairly unsophisticated software programs. The important part being that they manage money. Now, could they have legal implications? Could they be legally binding? Perhaps. Perhaps, especially if combined with some kind of written legal contract. But there are many jurisdictions in which various forms of agreements, whether written or not, are considered legally binding. So there's no reason why a smart contract could not be legally binding. However, this depends on the jurisdiction, and it also depends on what the legal precedents are. And until there's more established case law in this case, and I'm not a lawyer, so I'm just giving you my opinion on this, until there's more established casework on this, the term smart contract is very, very loosely used and should not be considered a contract. So for the second part of your question, what happens if one party defaults? Well, if the smart contract handles that particular case in its program, then something happens. Something happens on the blockchain. Is that legally binding or not? I don't know. You have to. And this is the reason not to leave a software construct. They do things on blockchains. Whether those things are within the law or accepted by the law, recognized by the law, with how the smart contract works. All right, let's see. We had some problems with the audio. Oops. Okay. How can you, and do I need to try again? And perhaps, Andreas, if you could please reduce the video quality using the slider on the Google Hangouts, that may help the situation by allowing more bandwidth for audio. Let me check. My apologies for the technical problems we are having. Unfortunately, I am in a part of the world where bandwidth is not plentiful. And as a result, I don't have enough upload bandwidth to make this more reliable. Let me try switching my connection and see if that helps. All right. Very good. Let's give it another minute. I want to make sure that this is working a bit better. So tell me if this connection is working better. Testing, testing, trying this. Let's see if this is better. Very good. OK. Let's go back to the previous question, and I'm going to repeat it. Sudhakar asks, what is the difference between coins and tokens? Can this be defined in layman terms? And as I said, I think that's a great question, Sudhakar. Now, the words coins and tokens are used almost interchangeably, but I think I can provide a somewhat helpful definition. And this is just my definition and my understanding of it. You may find that other people disagree. A token is something that simply represents some form of value. A coin is something that simply represents some form of value. But I like to think of coins as things that have their own blockchain, and tokens as things that run on top of other blockchains. So Bitcoin is a coin. Ethereum is a coin. And ERC20 tokens, Omni tokens, counterparty tokens, and things like that are tokens. They're not coins with their own blockchain. So that's the definition I use to coins and tokens. And if that works for you, that's great. But don't expect people to use that consistently. Sudhakar's second question, is a smart contract legally accepted? What happens if one party defaults? Sudhakar, the words smart contract are very misleading and confusing. A smart contract is a software program that runs on a blockchain. It's not a contract. It's a program. It's not smart. It's relatively unsophisticated. So I like to say smart contracts are. And is it legally accepted? That depends on jurisdiction. It depends on case law. It depends on precedent. It depends on a lot of things. And I'm not a lawyer, so I can't answer that. However, there are plenty of jurisdictions in which any form of agreement, whether written or not, even verbal agreements, are legally binding. So there is a good chance that some forms of smart contracts, if entered by parties who know what they're doing, are legally binding. But the interesting question, because smart contracts are operating in the domain of software and blockchains, if one party defaults, the smart contract may implement some kind of remedy. It may do something. It may move money, for example, if certain conditions are fulfilled. Whether that's legal or not, legally binding or not, accepted by the courts or not, is a whole other set of questions that have to do with law. But on the blockchain, something will happen. So smart contracts are defined in the software domain, not the legal domain. If they also have a legal component or legal aspect to them, that's separate. All right, let me check with and see if everything is working again. We've repeated both tokens and coins and smart contracts. I think we've caught up with the area where you could not hear me. I'm just going to wait to get confirmation that you can hear me. And then everything is better now. Very good. Fantastic. OK. Susanna asks, what would be the purpose of keeping a statement secret and later decommitting it and revealing it? Why hide and then reveal? What's the benefit? And give us an example. This particular concept, Susanna, which is a pre-image commitment, is used in cryptography for a number of different reasons. One example is used, for example, in Lightning Network. So Lightning uses a concept called a hash time-locked contract. And an HTLC, or hash time-locked contract, is basically a payment channel commitment based on the hash of a secret number. And what you do is you commit money that can only be redeemed if the secret, the pre-image, is revealed. And so the only way that the person who is at the end of the channel or sequence of channels can receive their money is if they reveal the secret to the person just before them, who can then only receive their money if they reveal the secret to the person just before them, causing the secret to roll backwards through the sequence of payment channels and getting everybody paid. It gives you a guarantee that the other party only gets paid if they reveal the secret. And if they reveal the secret, you also get paid, so they can't cheat you. The same concept exactly is used in atomic swaps. So for example, if I commit with another party funds on two different blockchains, let's say Litecoin and Bitcoin, in such a way that we're trying to do an atomic swap, but the only way I can cash the Litecoin they're giving me is to reveal the secret that allows them to cash the Bitcoin I'm giving them, then neither of us can cheat. So that's exactly how we first commit funds to a hash. Then we reveal the pre-image, and we reveal the pre-image in the transaction, in one of the transactions, which allows the other party to receive the other side of that atomic swap. That's a mutual guarantee that no one can cheat. Susanna also asks, if non-anonymous Bitcoin are the base cryptocurrency of the zero cash zero coins, which are anonymous, and since the Bitcoin and the addresses can be traced, wouldn't those converted to zero coins be associated with the same owner of the previous Bitcoin address it was sent from? Yes, indeed. And if you just left those zero coins where they are, they would. But once you start moving them around as zero coins, then that chain breaks. And so if they're converted back or simply use the zero coins, it's not possible to keep following that chain. So you can watch the Bitcoins go into zero coins, just like you can watch Bitcoins get converted to Monero or Zcash or other currencies that have very strong privacy. And you can watch the conversion and know that that other currency was received. But then once it's in that other privacy currency, you can't follow that trail anymore. Kirili asks, is there enough being done to confirm that smart contracts will work in the way that people have envisioned they will work? Kirili, I mean, the problem here is that the vision is far more expansive than what can currently be done with smart contracts. So people envision all kinds of things. Whether you can do all kinds of things is a whole other question. And I think people sometimes go way too far in coming up with these crazy ideas to replace things, even things that currently work, with smart contracts. The term smart contracts is beginning to become as vague and full of bullshit as the term blockchain or the term AI. It doesn't really mean what most people think it means. Kirli also asks, what should be done when things go wrong with smart contracts, i.e. where funds are lost due to coding errors and bugs? This is a really great question. In fact, it is the basis of a giant debate happening primarily in Ethereum right now, which started with the DAO bug, the decentralized autonomous organization that had a massive bug leading to the loss of $155 million. And in the end, the Ethereum community decided to revert that transaction. But in the process of doing that, split the Ethereum community into two. And now there's also Ethereum Classic, which is the part of Ethereum that refused to reverse that transaction. And this is likely to keep happening. So there's an ongoing debate as to what to do when funds are lost due to coding errors and bugs. On the one hand, people might think that this is a way to protect users, but unfortunately, who gets to make these decisions? And when you vest power in someone to make these decisions as to when funds can be reversed, not only does that power become dangerous, but the people who have that power are now liable. What happens when a government comes and asks them to reverse a transaction? They can't say, we can't do it, because they've already done it. So these are very dangerous and difficult decisions. The opposing argument, really, is that reversing things that were lost due to coding errors and bugs creates what's known as moral hazard. And moral hazard is a particular economic condition where people take more risks than they would otherwise take because they know that they will get bailed out. We find moral hazard in areas such as insurance and banking and stock trading. So when people know that somebody else will assume the risk, or they think that somebody else will assume the risk, they take on more risk. And as a result, that leads to more coding errors and bugs. If you knew that if a smart contract has a bug and you lose money, you're never getting it back, would you be more careful with auditing and selecting and very carefully putting small amounts before you put medium amounts, before you put huge amounts of money on top of a smart contract? And conversely, if you knew that if something went wrong, you'd simply get bailed out, would you be more reckless with the use of smart contracts? This is one of the things that is at the heart of this debate, and it's not resolved. There will be different blockchains that choose different policies as to how to solve this. All right, let's quickly check and see. Very good. Questions about blockchains for other industries. Why would a company use a permission centralized blockchain to track supply chain procedures? What efficiencies are gained over using a traditional database or the cloud? Phil, that is a very astute question, and if you ever find the answer to that, I would love to know it. Other than the fact that it allows you to stick every possible new buzzword into your marketing brochure, perhaps raise a whole ton of money in a underground ICO from a non-extradition tax haven country and bamboozle a ton of investors, I'm not quite sure what the point of these centralized permission supply chain blockchains is. In fact, the very word centralized blockchain is an oxymoron. And permissioned blockchains are almost equally an oxymoron. Blockchains are structures that are useful in creating decentralization and open access. Making them centralized and permissioned completely removes the need for running a blockchain. And in that case, it is simply a very, very inefficient database. You can imagine certain scenarios where a blockchain type system could be useful for supply chain, primarily for organizing supply chain interaction between partners who do not trust and who want a neutral, censorship-resistant, decentralized platform that serves their needs in a deterministic, predictable manner where no one is in control. That's what blockchains do. And for that purpose, you can imagine a supply chain blockchain would be very useful. However, that implies that you're using the supply chain across multiple participants in an industry. And the problem is they all have to agree to do that rather than try to jockey for a position and massage the standards until they get relative advantage, as always happens when these things are designed by committee, which is exactly why successive efforts at standardizing IT infrastructure and systems in industry committees fail and fail again and again and again. And it's exactly why things like the internet, things like the web that have emerged from neutral, research-oriented, scientific, open source endeavors have succeeded again and again and again. So let them try. Let them try to create a supply chain. In fact, what we're going to see is every company tries to make their own. None of them are interoperable. All of them give too much power to the company that owns it. Therefore, none of the competitors will want to use it. Therefore, it's just an inefficient database. Millions of dollars will be wasted on this bullshit. Phil has some more astute questions for us, all of which reveal some very interesting gaps in this idea of using blockchains for other industries. Would someone who uploads a hash of a music file on the blockchain prove that he, she is the first creator? Yeah, exactly. That is precisely the problem with trying to use blockchains to do digital rights management and provenance and all of the other stuff, which is that garbage in gives you garbage out. If you have a blockchain that guarantees that information is recorded accurately forever, that doesn't mean that information is true. It's only true if you can validate it with consensus rules that remove centralized power. But if anybody can simply put a hash up, that doesn't prove anything. You can't prove identity, you can't prove provenance, and you cannot prove ownership. And if you have a third party proving identity, provenance, or ownership, then it's not a decentralized blockchain. It's simply a database for registering the decisions of a committee, registry, agency, etc. Again, an inefficient database. Furthermore, using hashes to identify unique pieces of content like music or video has been proven again and again and again to be completely pointless, because all you need to do is change one bit and the hash won't match anymore. So you can't verify that a piece of content is the same. So all of this, really, I think I just demolished the ICO pitch and white paper of at least 20 different startups that are playing around with this concept. But the truth is that there really isn't much of a use case for provenance of music and other things like that simply by doing proof of existence. OK, let's destroy industry number 3. Phil asks, how would a patient holding his private key make the healthcare record management simpler? How could blockchain-based healthcare data be accessed if a patient who holds the private keys is in a coma? Well, fortunately, most of these things have been designed by startup people who seem to be in a coma when they were writing the white paper, because none of this makes any sense. The idea that you would put healthcare data, which is the ultimate most private data, on a public distributed ledger is asinine at best. Healthcare is probably one of the most narrow applications for blockchain technology, despite the fact that millions are being raised by companies at the moment to do healthcare records management. Ask yourself this: which problem in healthcare records by a global, neutral, censorship-resistant, decentralized system? Because that's what a blockchain is. Is someone trying to do censorship on records management? Is someone trying to introduce non-neutral data in healthcare records management? Is someone trying to artificially raise borders in healthcare records management? Is it a problem that the healthcare records management participants do not trust each other and cannot vest power in anyone? None of these things are really solved by a blockchain, because the problems in healthcare records management are not problems that relate to blockchains. So again, be very skeptical about industry applications of blockchain. Tim asks, how big in terms of storage will the Bitcoin blockchain get? Please elaborate on potential size. Well, I'm thinking about this big. Honestly, it's impossible to tell. It very much depends on how the future of optimization and scaling in this environment plays out. How much of the traffic is on-chain versus off-chain, how the traffic itself is optimized, the optimization and compression of transaction data. There are many exciting opportunities there, including things like signature aggregation using Schnorr signatures, Mimblewimble, and other techniques like that that just came out and were recently discovered just in the last 2 years. Lightning Network, that's maybe 5 years old as a concept, really only 3 years old as a seriously studied concept, and a few months old as a practical application. We have no idea of predicting how these things will bend the curve of growth, because all of this is about changing the curve of the growth of this system. It depends precisely not just on how much adoption we get of this technology, but how each additional unit of adoption of this technology and each additional transaction adds data to the blockchain. But predictably, the Bitcoin blockchain is going to get big. The good news is that storage and bandwidth are also growing quite fast. And so really the question is about the balance. Can we keep the growth rate of blockchain data, and specifically what's called IBD, the initial blockchain download, which is all of the data you need to download in the very first instance in order to fully sync the chain? Can we keep that to within a manageable and affordable level so that many people can participate in running full nodes without that being purely the domain of very, very large corporate data centers or just miners? That's important to maintain the decentralization of validating transactions. But again, that's really a design decision. So it's impossible really to say how far that's going to go. Tracy asks, can a block with hash data, such as an academic certificate hash stored and not returned, also have regular mineable transactions and therefore be treated just like any other block? Tracy, yes. In fact, the transaction that has the op return in it can also have other things like regular payments. Only one of the outputs needs to be an op return. Outputs in that transaction could be payments. So you can embed it that does other things as well as the op return. And of course, that the transactions and the block is just like any other block. Marcus asks, what exactly is meant with metadata? Are metadata visible and useful? Yes, Marcus, metadata is data that refers to something external to the system in which it's stored. So in Bitcoin, all the data that's about Bitcoin is data. And any data that's not about Bitcoin, but about something else that's stored inside Bitcoin is metadata. That's one of the ways. Of course, the term is probably a bit more flexible and vague than that. How could I upload a hash of a document in an op return field myself? Is there a special command on Bitcoin Core which allows me to do so? I don't believe there is. There are a number of other applications. Probably the best, there's a couple of good ones. One is called proof of existence, and I believe it's at proofofexistence.com, which allows you to upload the hash of a document and put it in an op return for a small fee. Another one is a more developed protocol called Open Timestamps, which is a project by Peter Todd, which is really interesting because it scales the ability to do proof of existence for billions of documents by aggregating in Merkle trees and putting only the root of the tree in each op return transaction while storing most of the metadata off the chain on Open Timestamp servers. So it's a good compromise solution. Open Timestamps is what you're looking for there. Marcus asks, in the same manner, could I upload any text I want on the Bitcoin blockchain as long as it's less than 80 bytes? Yes, you can. And finally, Marcus asks, could Ethereum be used more efficiently for storing hashes of documents instead of the Bitcoin blank? Yes, Ethereum could be used more efficiently for storing hashes of documents instead of the Bitcoin blockchain. And the primary reason is that Ethereum will allow you to store a lot more data, and as a result, has bigger scaling issues than the Bitcoin blockchain. So on Bitcoin, you can store 80 bytes in each op return, and it will cost you a transaction fee to include that in a transaction. With Ethereum and a smart contract, you can store quite a lot of the transaction fee, but there's no 80-byte limit. It's really a matter of metering that with gas. In fact, there is a particular type of contract called a deed or non-fungible token, which is basically storing hashes of things. These can be deeds like real estate titles or CryptoKitty hashes or various other things that are non-fungible, unique items, and storing those hashes inside a tokenized contract that allows you to transfer these tokens from person to person or from owner to owner. And that's called ERC 721. It's rather interesting. All right. Katerina asks, how is a token singled out and designated to represent, for example, ownership of a house? I can decide that one particular token will represent ownership and then code that into the token. Can you explain how this works? Well, Katerina, usually the way this works is you have an external data store. And this could be something like a decentralized file store like IPFS or Ethereum Swarm. And you would store some PDF document, for example, the deed of the house or some other title, or a reference to a title registry, such as a municipal, state, or government registry of titles. And you could take all of that information and encode it into a token. Now, the real question is, if you transfer that token to someone else, does that also transfer the title? In most jurisdictions, no. What a lot of people are trying to do is get laws passed that recognize the transfer of ownership of the asset, the house, when the token that contains the title or hash of the title is transferred. So that's a bit harder, really. This is the difference between software and law. Just because you can transfer a token in software doesn't mean that you can then take that token ownership to your local planning office and say, hey, I own this land, I own this house, and have that legally recognized. That's one leap further down. Katerina asks, can a program token still be traded on an exchange, and what value would that token then have? Its intrinsic face value or the value of the asset it contains ownership for? Yes, a program token can be traded on an exchange. In fact, it's impossible not to have a secondary market emerge for things like this. You can't stop people from trading things. Markets will emerge even on things absolutely great. Happen, and they happen if you put land or asset or a car or a boat or a plane, trade on an exchange. Value that have depends. Buying that token the underlying asset. The ownership, the uncertain they are, the more discounted that token would be, all the way down to 0 if they didn't believe that this conveyed any form of ownership for the underlying asset. So that really is about how do you tie ownership of a token to ownership of an asset that's not on the blockchain. Simon asks, regarding the child pornography incident on the blockchain. And so if you haven't heard about that, there was a recent article about a German team of researchers who claim to have found links to child abuse images, as well as potentially some grainy photograph that they were able to reconstruct from data scattered across many, many different transactions and blocks. Simon asks, is there a way of preventing such instances without hurting the core values of Bitcoin? No, there is no way of preventing such instances in any case, whether hurting the core values of Bitcoin or not. There is no way of preventing instances of people being able to embed data inside other data. I'll continue through these questions, then I'll give you some more insight on this. Simon says, they talk about everyone engaging in child pornography possession who has a copy of the blockchain for the full node. Is that really the case? Well, this is the giant leap. This is the leap from going from there are some links in the blockchain, and there are potentially some data that, if reconstructed by special software, will produce a grainy image of child abuse, scattered across hundreds of transactions, with that means you possess child pornography if you have a copy of the blockchain. With that leap, we can also look at other organizations that possess child pornography. Facebook possesses child pornography. There is potentially images embedded in hundreds of pictures of puppies all over Facebook. There may be images of child abuse embedded in those. There is special software that can take these images of puppies and reconstruct them. There may be child abuse images right now that they haven't removed yet. They're in possession. So is everybody who accesses that content. You're looking at a picture of a puppy. Maybe it has a fragment of a photo inside. Who knows? It might be in there. And of course, that means that Twitter, Facebook, Google, Amazon, every internet service provider, every phone company, and every data carrier is also in of child pornography because it is possible to embed data inside other data in ways that requires extraction. And in fact, of all of those things, the blockchain is the least efficient way of doing it and the most expensive way of doing it. Do you know who else has a copy of child pornography? The National Security Agency that hoovers up all of this data and stores it by the terabytes. So we should say at that point that the one organization that has the largest stash of child pornography on the planet is the National Security Agency, and they make that available to every one of their analysts, given a good search. Would pruning the chain solve the problem of storing bad content, asks Simon. Sure, you could prune the chain, and that would remove the bad content. But again, that doesn't stop anyone from putting more data inside data. And just because you removed it from your blockchain doesn't mean you removed it from all of the pictures you just downloaded from Facebook. Shouldn't law enforcement be happy that links are stored on the open Bitcoin blockchain so they can go and take down the actual hosting site? Yes, they should. In fact, they could also try another great place where links are stored. It's called Google. Could you explain how the op return script works and how it makes transaction output unspendable? Op return basically stops script execution. As soon as it's analyzed by the script engine, script execution stops immediately. So if you put op return inside the transaction script, it's unspendable simply because if you then refer to that input in another transaction, the script execution will try to validate it. They'll arrive at the op return opcode and return false, and you're done. That is not spendable. It's an invalid transaction. So just one final comment on the idea that there is child pornography on the blockchain. 4 or 5 years ago, when I first got into this, one of the discussions at the time was that eventually the propaganda against this technology would be that people use this technology for terrorism. And I made the case that, yes, in fact, people will try to associate this technology in the most obscure and ridiculous ways to all of the terrible evils that exist in the world: terrorism, child pornography, etc. And of course, child pornography is really a very special effort at propaganda, because what it does is it forces all decent people to immediately stop critical thinking as they recall a very, very effective mechanism to demonize any kind of technology. The logical train of thought that says that data can be embedded inside data, and therefore there is child pornography on the blockchain, makes absolutely no sense. All it takes is about 2 seconds of critical thinking to realize that the entire internet is basically subject to that same problem of data being embedded into data. The fact that someone would need to download software from hundreds of transactions to produce one grainy image that they could easily find on Google doesn't seem to reach that level of critical thinking. And the reason is because you don't get 10 seconds of critical thinking. Within second 1, every decent human being has switched off because of revulsion by association to child pornography. And if you think that's accidental, you're being very, very naive. There's this great cartoon that is circulating that shows Uncle Sam holding a box of propaganda, it says on the side, and he brings it up to the door, and the person behind the counter says, "How would you like me to wrap this?" And they have two wrapping papers, terrorism or child pornography. So if you want to wrap propaganda in something inflammatory and create the perfect conditions for people to have a knee-jerk emotional reaction without an ounce of critical thinking, those are the go-to things. Well, people are beginning to take this technology seriously. It is clear that when you create a system of money that bypasses the central bankers, some parties become absolutely desperate to find a way to malign this technology. And so they throw this at it. And it doesn't make any sense whatsoever, but it creates some great clickbaity headlines, and it makes decent people recoil. And so it works on an emotional level. I guess one way to look at that is that after the internet was demonized for exactly the same reasons, that didn't stop the internet. And eventually people figured out that this was propaganda. It still works in a lot of countries. There are a lot of oppressive countries where they use this kind of propaganda to curtail freedom of speech, to prevent people from protesting and using the internet to reveal, for example, the corruption that exists in various forms of government. And they use these excuses. But the truth is that in terms of mathematics, you can always embed data inside other data. The fact that it's there doesn't mean that it's accessible. You have to write special software to do that. And you should think very carefully what it means. What is exactly the criminal behavior there? Sure, it's special software and reconstruct an image. They are very much in possession. That is absolutely revolting and criminal behavior, but it has nothing to do with blockchains. Stephen asks, could a blockchain be implemented to distribute credits to the elderly who could use up the collected credits to pay their rent or social activities? For example, supposing the credits are validated by certain authorities, priests, city social service, clerks, etc. Can you see a blockchain platform be created for that application, or could an existing one be used to timestamp and validate the credits? Can a system be created where buying and selling of these credits is prohibited? Stephen, I'm sorry to say that while what you're saying is an admirable idea, and clearly I can see where you're coming from, what you're describing is money. And yes, you can create tokenized forms of money. But the problem is that when you create tokenized forms of money that you try to restrict the circulation, restrict the liquidity, restrict the places that they can be spent, and restrict who owns them, that reduces the value of that money. And in the end, you cannot prohibit people from buying and selling these credits. You cannot prevent secondary markets from existing in anything that is perceived as valuable. If something is valuable, it is traded. That is just the law of economics. That is the natural rules of economics. So you can't prohibit people from trading these tokens. They will trade them. They'll trade them on secondary markets. They'll trade them even if it's illegal to trade them. And if you try to prevent people from trading, all you're doing is you're discounting the value of that token. So people will trade it at a discount. The less liquidity and circulation and velocity it has, the more of a discount it will trade at, the more you erode the value of that token. So effectively, what you've created is simply bad money. And that bad money, people will try to get rid of and try to replace it with good money. And that's called Gresham's law. If people have two forms of money and one of them is considered bad and is sold at a discount, they will use only that to do all of their spending until they run out of it, while they hoard the good real money that they perceive to have greater value. Unfortunately, these basic rules of economics can't be violated, and we see these scenarios play out again and again. And again, we see them in places where you have hyperinflation, like Venezuela and Zimbabwe. You see it in places where you have demonetization, as we saw in India, where the demonetized notes flooded the market immediately at a heavy discount, as Gresham's law played out in reality. We also see the negative implications of using this kind of restricted script. These were very, very popular in company towns in the Old West. And they still are in certain places where disadvantaged and disempowered workers live and work inside compounds. For example, mining companies, oil extraction companies, resource extraction companies, et cetera, where the only credit they can spend is tokens that are issued by the company, spendable only at the company store to buy food and basic amenities. These are used as systems of control, and not a good system, and not a good outcome. They're used to control people for the most part. So while I appreciate your approach to do this in order to help people, unfortunately, the laws of economics will work against you, and in the end, it just becomes a poor substitute for money. All right, we've got all of that covered. Let's see if we have any follow-up questions. We have one follow-up question from Susanna. Zero Cash and Zcash, are they the same, or is one the equivalent of the other? No, they're two completely different systems. And they use different algorithms for their privacy. They just have similar sounding names. Some of the original research, there's some overlap in the original research, but that's about it. Juliana asks about quantum computing using various algorithms and whether that will affect the ability of blockchains to operate. It's very important to understand that the algorithms used in blockchains can be changed. And if we have widely available quantum computing, then we will change the algorithms that are used for encryption. No encryption system survives forever. All encryption systems have a life cycle, maybe 15 or 20 years before they become too weak to operate. And at that point, they have to be replaced by other algorithms. Quantum computing isn't magical. It simply changes the algorithms we would need to use. If we have quantum cryptography available for the masses, if we have quantum computers available for the masses, then quantum computers can be used to do the cryptography inside blockchains for the masses too. And if they only exist very, very sparsely distributed, for example, only in use among intelligence agencies, I can guarantee you that the last target they would want to attack is Bitcoin. In fact, maintaining such quantum computing capability without revealing to the world that you have it is a huge strategic advantage, because that same quantum computing capability can decrypt the keys that control nuclear missiles, the keys that control military communications, the keys that control drones, the keys that control government communications, the keys that control stock markets all around the world. That is a huge military strategic advantage. And as a result, it would be the best kept secret in the world. And I can guarantee you they wouldn't waste it on a bunch of nerds playing around with fake magic internet money. Very good. We've had a lot of questions, and I think we'll stop there. If you have further questions, please remember to ask them in the forums in advance of this course, so I can prepare for them and answer them in the context of the conversation. So thank you all for participating. This has been session 6 of the massively open online course for the master's degree in digital currencies by the University of Nicosia. This is Andreas Antonopoulos. It's been a pleasure answering your questions. I look forward to talking to you again in our next session. Please prepare your questions, ask them in the forums, discuss them amongst yourselves, and see you soon at a next live session.